Good morning, everybody. I hope everyone is doing well this fine Monday morning. My name is Alan Pendon. I am the Digital Demand Generation Manager here at Electro Rent, and I'm excited to present this webinar with VIAVI Solutions on simplifying the challenges of field testing multi-fiber connectivity. Now, this session will be recorded, and links to the recording, as well as the presentation, will be sent to everyone after the event. Today's speaker is Peter Damaris, with over 30 years of experience in testing and measuring all types of networks and infrastructure. Peter is currently a solutions engineer at VIAVI Solutions, where he specializes in fiber optics and Ethernet testing. Now, just a little bit about Electro Rent. We are the largest testing and technology services provider. We have over $1.2 billion in inventory that equates to having more selections for your testing needs. Electro Rent has invested more than $100 million on new inventory. We have over 122,000 solutions in stock, 27 offices and inventory centers that can deliver to over 100 countries, and over 600 specialists to help you. Now with that, let's get started with the webinar.
Okay, can you see my screen?
Yes, I did.
All right. So welcome everyone. My name is Peter Damaris. I'm a solutions engineer for VIAVI Solutions. So today's topic, we're going to go through simplifying the challenges of field testing multi-fiber connectivity. And it's really going to be an introduction to MPO and MTP cabling. So let me, all right. So agenda for today, like I said, intro to MPO, MTP connectivity. We'll learn to identify the various types of MPO connectors, understand how MPO connections are used in various network architectures, and then talk about the best practices for handling, really for inspecting and cleaning the MPO connections. And then we'll talk about the test equipment that's used and the right test equipment to use for testing and working with MPO cabling. So I'm going to start with the note down at the bottom here. So as I go through this, we are going to talk about MPO versus MTP, but I'll be referring to both of connector types as MPO. So when you hear me say the term MPO, it's interchangeable for the sake of this presentation with MTPs. So to start, so MPO, it stands for it's a multi-fiber push-on. And I apologize right out of the gate. I'm showing a slide with no graphics, just all words on here, but just bear with me when we get through this one, the slides get better. So MPO stands for multi-fiber push-on. MPO, it's a generic fiber connector type. So any manufacturer can conceivably make an MPO cable and equipment. There's no standards. Like I said, it's a generic term. MTP, on the other hand, it's trademarked by US Connect. So per US Connect's website, and I just cut and pasted this from their website, the MTP connector is a high-performance MPO connector engineered for better mechanical and optical performance. So let me just talk about that for a second here. So it used to be there was an MPO connector out there. It was a multi-fiber ribbon connector. And then US Connect came out and they said, hey, we're going to take that MPO connector, we're going to enhance it, make it even better. And then they trademarked it MTP. So years ago, it was always known if you had an MPO versus an MTP type connector, that the MTP was the golden standard. I did a webinar one time and made that statement, and somebody contacted me from a manufacturer afterwards and said, well, we make MPOs that are just as good as an MTP, but we can't call it an MTP because it's trademarked. So, so MPO and MTP is kind of pretty much interchangeable. There are some advantages that US Connect has trademarked to the MTP connector. There's about 5 or 6 different little tweaks that they've done to enhance it and make it a higher performance MPO connector. So I won't really get into those, but one, just for example, when we talk about the pins on the connector, The MTP has rounded pins, so when you slide the two cables together, it doesn't scratch or chip away. It's just an easy guide into it, versus the MPO is kind of shared off at the top. But so that's the primary difference. MPO, generic, anybody can make it. MTP, trademarked by US Connect. It's a beefier, kind of a little higher standard version of an MPO connector. So MPO cables pre-terminated, and they support speeds from 10 gig up to 400 gig. So it's not like you're going to be working with fibers or ribbon fiber and be out in the field for the most part. You can terminate in the field. There are MPO connectors that can be field terminated, but most of the time, what we see in data center applications and that are that these come pre-terminated to specific lengths. And the most common fiber count in an MPO connector is 8, 12, 16, and 24. I'll talk a little bit about those. And then proper polarity of these connections from end to end. So all the way from the transmit port to the receive port on the other end can get challenging. And we'll go through that as well. I'm going to turn my pointer into a laser pointer here. So why so popular? So here's a LC, kind of a duplex fiber panel here. And then this is showing an example of this right here is 24 fibers. So 24 individual fibers. There's 12 LC duplex connectors here. This right here is 144 fibers. So you can do a lot more with an MPO, a multi-ribbon connector, than you can with just individual fibers. So there's a lot more density in that same footprint. And then over here, it's just showing MPO lets you deploy many fiber ports quickly. So this is just showing a fan out cable where it's going from a ribbon fiber on one end out to individual, individual fibers on the other side. So where do you find MPO connectors today? Pretty much everywhere. Anywhere where there's fiber optic cabling being run, you're going to see ribbon fibers. We just did a big project with one of the major service providers where we were running, they're running MPO cables up the side of cell towers. So it's everywhere out in the field. We've done multi-dwelling units where it's fiber to the home. We'll see MPO cables being deployed. So it's deployed in just about every network, core IP networks, metro networks, access networks, and then the enterprise premise space. So today I'm going to be referring a lot to this space here, but everything I talk about applies to each one of these other markets or applications as well. Oh, there we go. So the two different types of MPO cables that you'll hear a lot about, one of them is trunk cables. And trunk cables, it's the same number of and type of connectors on both ends. So a trunk cable might be a 144 fiber cable with 12 fiber MPOs on the end, and that'll be the same on both ends. These are usually, like I said, pre-terminated. This is an example right out of a data center that I was at. These 144 fiber trunk cables coming into the back of this panel. And then on the front side, these are MPO connections. So there's 4, 8, and then this last one, they only use 11 of them, 3 MPOs here, and the last 12 fibers, they break out into an MPO to LC cassette. So that's where a breakout cable would come into play. MPO breakout cables can break into 4, 6, 8, or 12 different connectors. These can be LC, SC, ST. So you've got an MPO coming in the back, and you've got these individual fibers on the front side. So many times users will utilize an MPO 12 fiber for an MPO 8 application. I'll talk a little bit about that in a second. In these cases, 4 strands will submit signal, 4 strands will receive signal, and then the middle 4 lanes aren't used at all. So we'll talk a little bit about that. But as we're going through this, if I mention trunk cables, it's just an MPO on one end, MPO on the other end. And then a breakout cable can be MPO on one end, and it's broken out into LCs, SCs, STs, whatever on the other end. Another key thing to consider when looking at MPO connectors, there are different grades of them. This one here, US Connect, this MTP, they make an Elite. If you look at the same connector, that's just a standard single mode MPO connector from, again, it's MTP, so it's from US Connect. Here's their Elite one, has a IL insertion loss maximum of 0.35 versus the standard is 0.75. So a standard MPO or MTP connector has an insertion loss, maximum insertion loss of 0.75. You can also get an MPO, so it doesn't have to be an MTP Elite, in a low loss version. So just kind of keep that in mind as I'm talking about test equipment. Any test reference cards that you use for you to reference out your test equipment, we always recommend using a low loss type MPO connector or a low loss TRC, they call it, a test reference cord. So a lot of times when you reference out the units, you want to get them to 0.7 dB or less. Well, if one of your connectors is up around 0.73 or 0.74, you're never going to be able to reference that equipment because you're already outside of your loss budget. So just keep that in mind. This applies to the MPO connectors themselves. Again, there's a low loss version and then there's a standard version. All right, the jacket on MPO cables is significant as well. So single mode, typically, and I have seen black, we've seen different colors depending on the application, but for the most part, the industry standard is yellow for single mode, this aqua for multi-mode, and then there's a new one out, some manufacturers, this is mostly in the UK we see this. I haven't seen this deployed in data centers yet, but some manufacturers introduced Erica, or they call it Heather in the UK. Excuse me, it's violet colored connectors for OM4. So for the to distinguish them from aqua OM3 type connectors. So, but the two that you'll primarily see are these two right here, the yellow jacket and the aqua jacket for multi-mode. So let's jump into exactly what makes up what is MPO and what is an MTP connector. So these are the key parts of it, no pun intended, but this first one is the key to the top of it. This is what allows you to only plug that connector in one particular way. You may hear the term key up or key down. It's just a matter of how this is plugged in. If it's plugged in upright like this, it's key up. If it's flipped over and plugged in key down, it's called key down. The fibers, these white dots in the middle are all of your fibers. So in this case, we've got 12 fiber. This would be a 12 fiber MPO connector. Down below here, I show what a 24 fiber would look like. So it's the same physical footprint, the same size. It doesn't get any bigger if you go from 12 fiber to 24 fiber MPO, but it's how the fibers are put into that connector. So it's, in this case, it would be 2 rows of 12. I mentioned earlier that some of the other popular configurations are 8 fiber or 16 fiber. So same thing would apply in an 8 fiber MPO. It would be fibers 1, 2, 3, and 4. And then these aren't there. These are just black, just it's the ferrule. There's nothing there. So 1, 2, 3, 4 are blank, and then 4 on this end. So that would be an 8 fiber MPO connector. And then a 16 would be the same. It's just 8 over 8. So the ferrule on an MPO, let's call it the polymer or the glue that kind of holds all this together, is it's a polymer ferrule, and I'll show you an example of that in just a second as well, because a lot of times guys will look at a MPO connector and they'll see all these little bumps, and I've got a picture of it. They'll see all these little bumps and they think, oh, that's dirt, but it's not. It's a polymer ferrule versus a ceramic ferrule. that would be on an LC or an SC or a different type of a single fiber connector. And then one of the key things here is these alignment pins and sockets. So this is what allows you, and I've got a slide for this, we're going to go through each one of these, but this is what allows you to match up this fiber with the fiber that it's being paired with, mated with. It's these alignment pins or sockets. And these, it either comes, I say pins or sockets. This is a picture here showing sockets, and then the pins would be coming out of here. All right, so this is where I was saying, on the right-hand side here, we've got just a simple LC simplex connector, just one single fiber. If you look at that through an inspection probe, you've got this nice white ceramic ferrule around the outside of it, and then you've got the fiber in the middle here. When we look at an MPO connector, again, because it's a polymer ferrule, you'll see all these dots and bumps and little, looks like little blisters on the ferrule, and that's just because it's a polymer. It's multi-fibers in this versus just single fiber in the LC. And then it's 6 times or 12 times density, or we've got 8 and 16, 24, and 12 fibers. So, but just keep that in mind when you look through an inspection probe at the end face of these MPOs. That's what you're going to see, and it's not dirt. It's just a different material. Multi-mode versus single mode. So 99% of the multi-mode MPO connectors are just going to be a flat polished fiber. I'll talk a little bit about that. Versus single mode, 99.9% of the time they're going to have a green cap on here, and they're APC, or an angled polished fiber. So connectors for single mode fiber have angled ends to minimize back reflection, while multi-mode is typically flat. So just what do I mean by back reflection? The example I always give is you're standing in your kitchen and you get your high-powered flashlight and you go to shine it out the window, and that window is just a flat glass window. That would be an example of this flat polished fiber. The light is going to hit that window and bounce back into your eyes, and you're going to get a reflection. Well, fiber optic equipment doesn't like reflection. We don't like that. It doesn't like that extra light coming reflecting back at it. So what they use is an angled polished fiber, and this has an 8-degree angle to it. So now if you're standing in your kitchen and you've got that high-powered flashlight that you want to shine out into the backyard, if you tilt that window 8 degrees and you shine that light, the light's still going to go out into the backyard, but it's not going to reflect back into your eyes as much. It's going to really minimize that back reflection back at you. So in a data center world, or in just an Ethernet or data world, we want to minimize that reflection coming back at any of the transmitters or any of the test equipment that we're using. And this is what's used. It's an APC connector, or angled polished connector, and multi-mode is just a flat connector. And that's what it would look like if you looked at it from the side, just flat on top, 8-degree angle on that one. One other little note here is the angle, when that fiber is angled like that, is going to be where the key is. So on that last slide, I showed that there's a key on the top there. That's the way the angle is going to be, on the same side as that key. So this is just showing those pins. And so we've got the guide pins on here, and it's going to click in. This is just an adapter that's shown here. We've got the male cable, the female on this side, and it's going to make a good solid physical contact. So the whole key to those pins, if you tried to mate a unpinned to unpinned cable together, even though you're putting it in this coupler, there's no way you're going to get all 12 of those fibers to align perfectly. That's where those alignment pins come in. It's going to match up all 12 or 24. If you've got 24, even more difficult, all of those fibers from one cable to the other. Polarity. It's another big thing when dealing with MPO cables. So the three industry standards define three different polarity methods. So they call them methods, but then we look at it, it's type A, type B, and type C. So as we mentioned over here on the left, for fiber links to properly send and receive data, the transmit at one end of the cable must match the corresponding receiver. So obviously transmit has to go to receive. And with these three different methods of polarity, it gets pretty difficult. So you've really got to pay attention to it. So the type A cables is just straight through. So fiber 1 goes to fiber 1, 2 to 2, 3 to 3, all the way through. So the two connectors on each end of the cable are straight through, no changes to them. The problem with that, if I plug this in to a server or a switch, the first 4 are usually your transmit, and the last 4 are usually your receive fibers. So if I plug in, I'm going to be plugging fiber 1 into transmit on one side, and if I plug the same thing in, it's going to be plugged into transmit on the other side. So I'm going to have transmit going to transmit. So what we use is they call it a flip. So type B cables actually do this flip for you. So pin 1 goes to 12, 2 to 11, 3 to, and so on and so forth. So it flips that signal for you. So when we plug this in, pin 1 is going to be transmit, and it's going to be going to pin 12, which is a receive. And then this one here, I don't see very much. This is where it's a pair flip. So 1 goes to 2, 2 goes to 3, 2 goes to 1, 3 goes to 4, 4 goes to 3. The other thing in an MPO cable, so not only is it pinned out properly on each end, but these fibers are all color coded to ensure that everything is punched down properly as well. So you've got color coded fiber strands, and then you've got the way it's punched down into the connector on the ends. Next up, polarity check. So we've just talked about the different types of polarity. So for existing installations, the end-to-end polarity is often not known. So you go into a building, you go into a data center or a central office, whatever, you don't know what that polarity is going to be. So a test equipment that has some type of a test polarity check on it, they call it a fiber map or a wire map tool to it, is going to be critical. It's going to allow you to know exactly what the polarity is of that system, but it's also going to allow you to check any individual cables. So when you see a jumper or a trunk cable or even a breakout cable, you don't know how that's wired, how that's punched down, if it's A or B, because unlike a copper cable, let's say a category 5E or category 6A cable, it's labeled right in the print legend on the jacket of the cable what that is. In this case, they typically don't put what the polarity is because they don't know. This is a manufacturer of the fiber optics is making the bulk cable. That's where the print legend's applied. Then it goes to an assembly house or where they're terminating and putting the connectors on the end. So it's not printed right on that cable jacket, the fiber jacket. So having a tool that'll allow you to go in and quickly test it is critical. So there's another little thing, and I learned this a couple of years ago. I had no idea what this was. I just figured it was the manufacturer did this, but there's a little white dot on the side of almost all MPO connectors. And the reason for that is that's what identifies where fiber 1 is. So if I take this cable and I plug it into an adapter, and it's a key up to key up adapter, these fibers, I'm going to see a white dot. I think the next slide actually shows it. I'm going to see, I could see 2 white dots on the same side. Well, I know that that's going to be a type A because I've got the white dot, which is signifying fiber 1, going to a white dot on the other cable, which is fiber 1. So I'll know 1 is going to 1. If that's flipped, if it's a key up to key down, then I'm going to see a dot on one side and no dot on the other cable. So it's a unique unique thing that kind of became part of the standard and part of all the manufacturers. They put that white dot on there, and the only purpose for that is to show that it's where fiber 1 is and to help out with polarity. So here's another example of that. If I've got fiber 1 here and fiber 1 here, a type A adapter is going to be key up to key down so that the two fibers line up. So this would be a pass through or a straight through type configuration. Nothing's going to change here. You're just joining these two fibers together. Fiber 1's going to 1 and all the way out to 12's going to 12. Type B configuration, it's key up to key up. So now we've got position 1, so we'll have a white dot here, is going into fiber 12 because we've flipped that cable over, and 12 is going to 1. So these adapters are critical. They come key up to key up when you're mating them, and you can get it key up to key down. So just keep that in mind as well. Polarity with ribbon fibers definitely gets tricky. And then this is just an example to show just what I was talking about. So here we've got a panel or a switch. Coming out of there, we've got a receive fiber, and down here we've got a transmit fiber. If we've got all type A cabling and equipment going through here, then there's not going to be any flip at all. We're going to have transmit going to receive, transmit going to transmit. So at some point, even in a polarity A, there has to be one component that's a B or that does this flip. It could be one of these couplers, it could be a cable. So in this case, in this example that's given here, we've got a type B cable here to start things off. So transmit coming out, position 1 is flipped, and now it's going to position 12. So we've gone transmit to receive, and now throughout this entire run, this entire link, we now have it's all type A cabling, and now it's going to go transmit to receive. Similarly, type B, we just need to make sure we have an odd number of flips. So if not, we'll be flipping it back to A. So in this case, this is a B cable again. So we've got B, we're using an adapter here. So this B becomes A because we've made it two that have flipped together. It jumps back, and now it's back to B. Now it's A, and now it's B. So we did the flip. So you always have to have, if all of your components are type B, you have to have an odd number of flips somewhere in that network, that fiber distribution. Just again, you need to get transmit to receive. So some of the applications. So I just went up to 100 gig here in this chart, but you can get 4 lanes of 50 gig for 200 gig. So there's a lot more, but just to show how these ribbon fibers are used. So 10 gig, if you've got just one lane, you're getting 10 gig out. If we use a ribbon fiber, now we've got, and you'll see on the ends here, there's no number here, it's just SR. SR4 means we're using 4 lanes. SR10, we're using 10 lanes, and a 4, we're using 4 lanes. So in this case, we just have, this would be just an LC or SC type cable, just one single lane. This one here is using 4 lanes. So we've got 4 transmit, 4 receive. So 4 lanes of 10 gig is going to give us a 40 gig speed coming out. And then the different technologies would be 40G base SR4, or for single mode, the long range 40G base LR4. Here's another example. This is 10 lanes. So this would be a 24 fiber MPO cable. So 10 lanes of transmit, and we would need 10 lanes for receive. So 10 lanes at 10 gig, we're getting 100 gig or 100 G base SR10. And then here's just using another example, just using 25 gig, 4 lanes, 100 gig. So, excuse me, when we're using just 4 lanes, again, the first 4 fibers, 1 through 4, are transmit, 9 through 12 of that 12 fiber MPO are receive. The 4 fibers in the middle aren't used at all in this scenario. Similarly, in this case, if we've got, again, a 24 fiber MPO cable, so it's 12 on top, 12 on the bottom. In this case, we're not using fibers 1 or fiber 12. We're just using the 10 middle fibers. So 10 on top, 10 on the bottom, transmit, and 10 for receive, and we're getting 100 gig out. And this just shows some of the standards. I won't get into all the different standards, but the IEEE standards, it defines 10 gig lanes for 40 and 100 gig. It defines 25 gig lanes for 100 gig. The standard defines 50 gig lanes for 200 gigs. So this would be 4 lanes of 50 to get you 200. And these are some of the technologies. So this is that 12 fiber MPO. The first 4 are transmit, the last 4 are receive. So in this case, 10 gig, and we're trying to get 40. It would be 10, 20, 30, 40 down here, transmit and receive. This is a sample of an 8 fiber MPO. So one of the things to keep in mind, if you're working with some manufacturers, they've got 8 fiber solutions that are out there. Now, Corning's got their Edge 8 solution. What that is, there are no fibers in the middle here. So if you're testing a fiber cable, your tester doesn't realize that there's no fibers in the middle. So it's going to run a test and it's going to fail. It's going to say, hey, fibers 5, 6, 7, and 8. In this case, they're completely broken or extremely dirty. So in this case, you want to have test equipment where you can go in and turn on or turn off those middle fibers. So in this case, I've turned on fibers 1 through 4 and 9 through 12, and you can click on it and turn them on or off. So in this case, I would turn off fibers 5, 6, 7, and 8 if I was only using the first 4 and the last 4. And then that's right here, it says that eliminates false fails in the case of when 8 or fewer fibers are present in the MPO links. So if you've only got 8 fibers, the test is going to fail all the time because it's going to think that these are bad fibers in there. So in this case, you would turn off 5, 6, 7, and 8. Also, when you do turn off 5, 6, 7, and 8, the tester is going to give you pass and fail results. So even if you've got a 12 fiber MPO, it's only going to give you pass or fail criteria based on the first 4 and whichever ones you have turned on. So in this case, the last 4. So it's it'll still measure and test 5, 6, 7, and 8, but it's only going to give you your pass or fail criteria based on the ones you have turned on. In most cases, the big hyperscale data centers and that, they're installing 12 fiber MPO cables. And even though they may only be using 8 of those fibers, during the installation process, they want all 12 tested. So it's critical that all 12 fibers are turned on. And when you're doing your loss testing, you're checking the loss for all 12, so that if they're using an SR4 application or SR10 down the road, it won't matter. They know that that fiber has been tested and all 12 are good. When working with a single fiber, just an LC or a Sam Charlie, an SC type connector, it's pretty easy to get that fiber clean. It's pretty easy to inspect it, put your inspection probe on there. If it's dirty, you get your 1-click cleaner, you click it, and it's usually 99% of the time, at least that's what I've found, you can clean a fiber in LC or in SC or just a single fiber with one of those click cleaners. But when mating 2 fibers, if one is dirty and the other is pristine, the dirty connector or dirty end face will cross-contaminate the previously clean connector or clean fiber. So if this residue is drywall or concrete dust, if you're in a new build, which is very common in new data center construction, it could scratch the surface or get embedded in the fiber, causing it to pit. So at that point, you can't clean it. It's the fiber's damaged and you've got to throw it out. So this is just an example of a clean fiber. This is what you want to see. You've got 2 MPO connectors. You've got a good physical contact. Everything's clean. This is your signal coming through. There's no loss or very, very minimal loss because you've got a good connection and everything's clean. So that's what you want to see. That's the perfect world. This is what you might see. So here we've got an MPO connector on one side with a little particle of dirt on there. And we take another MPO on the other side, we mate them together, and now it explodes that particle of dirt. So now it's been broken up, and now you'll see this top section isn't making as good of a connection as down at the bottom. So when we test this, we're going to see that fibers 1, 2, 3, 4, 5, 6, and even 7, we've got some excuse me, back reflection coming back. It's hitting that air gap, hitting those particles and bouncing back. We've got a much weaker signal coming through on this side than what we were sending out, so we've got excessive loss. And then fibers 10, 11, and 12 may test perfectly fine. So it's critical on MPOs to clean those end faces, and it gets pretty difficult. Let me show you what we do. So this is a VIAVI thing. It's drilled into us. Inspect before you connect. So we always say inspect the fiber, don't clean it. The habit that I see most of the time is you go out, guy grabs his one-click cleaner, and before he plugs something in, he just cleans the heck out of it and plugs it in with no inspection. So that works a lot of times, and it reinforces bad behavior, because if that fiber was perfectly clean, and let's say that little particle or that dust or that little piece of sheetrock was on the end of the click cleaner, you've taken a perfectly good fiber and you've scratched it or pitted it or ruined it. So what we say is IBYC, inspect before you connect. So inspect it. If it's clean, then go ahead and connect it. Don't do anything to that fiber. If it's not clean, then go ahead and clean it and inspect it again and stay in this loop until you get it clean, and then go ahead and connect it. But it's highly, highly, highly recommended. Don't just grab a click cleaner and just start cleaning, because you can damage what was a perfectly good fiber. You can't make a perfectly clean, pristine fiber any better. You can only make it worse. So, like I mentioned, with an LC or a single fiber, it's pretty easy. You get your one-click cleaner out, click it, you get it clean almost every time. In this case, with MPOs, it's all or nothing. So if one of these fibers is dirty or 10 of these fibers are dirty, it doesn't matter. It's pass or fail is based on all 12 of these fibers being clean. To do that, it gets tricky. It's so click cleaners are good for cleaning end faces during network installations. You want to clean both the ports and the patch cords. So before you plug into something, clean the patch cord or the jumper, and also clean the port. And it uses this micro-woven, ultrasonically cut cleaning ribbon, which is blown up, picture of it here. So that's always the first step. Use that click cleaner. If after several attempts it doesn't, you can't get it clean, then it's suggested to do a wet to dry method of cleaning. So what happens with MPO cables and connectors is static electricity will build up between the fibers. And what that does is you'll look at it and fibers 2 and 3 might be dirty. And then you take your one-click cleaner, you clean it, and now you look at it and 2 or 3 are clean, but 9, 10, 11, and 12 are all dirty. And you clean it again, and then the dirt jumps, and it's jumping from fiber to fiber. Sticklers did they're a chemical company that makes clickers and different chemicals, but they did a whole study on this and found that that's what it is. It's static electricity that builds up. So as you're clicking, you're adding to that electricity, that static electricity. So the best practice is to use a wet to dry. You always want to finish with a dry clean or click. So they say apply a small amount of cleaning fluid to an optical grade wipe. So you put this fluid right onto the wipe, touch the tip of the clicker onto the wet spot that's on the wipe, and then go ahead and click whatever it is, your jumper or your port or whatever it is. What they don't suggest, or what you shouldn't do, unless you got unlimited budget, is to spray the solvent directly on the end of the click cleaner. As you can see, this is a woven material. So as soon as you spray that on there, it sucks up that cleaning solution into that fabric. So now it's going to take you 6, 7, 8 tries to get to a dry cloth on there to finish with that dry click. So you can do it. You can spray it right on there if you want, but it's going to eat up a lot of your tape in here because you're going to have to click 8 times to get it to that dry cloth on there. All right, so tier 1 and tier 2 fiber testing. So this is a little chart I put together. So tier 1, when we're doing a tier, you'll hear that those terms, the TIA terms. When you hear of a tier 1 certification, we're measuring length, polarity, and link loss. So 3 requirements of, obviously at the top here, we've got inspect and clean if necessary, but then it's length, polarity, and loss. So that's a tier 1 tester, called an optical loss test set. If this test fails, so this is actually a screenshot of VIAVI's, of our tester. It shows length, loss, and polarity. So length, this cable was 438.6 meters long. Polarity was B, and then my link loss was 1.35 and 4.23 on my other fiber. So I've measured length, loss, and polarity all on that MPO cable fiber. If this is to fail, if anything on here failed, if our loss budget was above what we put in, and it failed, we can't really tell where that failure occurred with a tier 1 tester, with an optical loss test set. In that case, we've got to switch to a tier 2 device, which would be like an OTDR. An OTDR is going to show you all the individual events along that fiber and show you which connectors failed, if there was a splice, a bend, a bad connector. It'll pinpoint the exact event. So it's a visual link view. So it's going to look at the entire link. The event, it's going to show all the locations of each event on that fiber, and it's going to give you your reflectance, your loss, optical return loss. So tier 1, you have to certify. If you're doing a new installation, if you're a contractor doing an installation, you have to do tier 1 certification. If it fails, then you do tier 2 certification. So again, tier 1 is length, loss, and polarity. So this is VIAVI's. We've got 3 different products that we sell into the MPO space that are designed specifically for testing and working with MPOs. One is our Fiber Check Sidewinder. It's a all-in-one, must have timing on that slide. It's all-in-one inspection tool. You plug the fiber at the MPO into the bottom of it, and it auto focuses and tests every fiber on that cable. And you can tell it if it's a 1x12 fibers going across, 2x24, or exactly what it is. Next one is our OLTS. We call it our MPO-LX. And this is what you have to use. This is just an example of that optical loss test set. You have to use an optical loss test set to certify. And this is the last time I'll click back on this. And then finally, this is that tier 2 solution. So this is our OTDR, and we use an MPO switch attached to it. So I'll go through these and show you a little bit more. One of the keys, so this is the MPO-LX. So this is the only tester, the only optical loss test set out there on the market today that will actually measure length, loss, and polarity. There are other MPO testers out there that have a native MPO interface on it that measure loss and polarity, but they do not measure length. So worldwide, we have 0 competition on this because it's the only product that can do a true tier 1 certification of an MPO cable, where we're going to give the results. And like I said, here's an example, here's a picture, here's the length, here's your loss, and here's the polarity right on the screen. So the MPO-LX, it's got a screen on both ends. So you can do your end face inspection. We talked about how important inspection is, especially with MPO cables. You can do that and it'll show up right on the screen of the unit. This here is called a patch cord microscope. It's an option. You can get it with or without. But you can plug that patch cord right into the top of this, or jumper or whatever, right into the top, and do your inspections right here. There's a focus button. You can zoom in, zoom out, and a test button. So built-in patch cord microscope to do your end face inspections, length, loss, and polarity, and then it's got screens on both the local and the remote device, which allows you to do inspection at both ends. You can start a test at one end, stop a test at the other end. Everything gets stored on this unit here on the MPO-LP. Regardless if you hit save at this end or at this end, it all gets sent to this unit and gets saved there. This is another unique solution. This is our T-Bird 4000 OTDR. This is actually a great tool for, it's a tier 2 tester, tier 2 OTDR. So it's going to measure all the individual events. So in this case, it's showing a splice here, a connector here, a bend on a connector here, and then the end of the fiber. So it shows each individual event. It shows the distance to each one of those events, and then gives you all the information about it down below. The key with this T-Bird 4000 is we can put an OTDR module on one side and then put an MPO switch on the other side. And this is an example. This is the MPO switch module. So now we're using an OTDR. We put a jumper over to the switch, and when we hit the start test button, all the OTDR knows is that it's testing a single fiber. What the switch is doing is controlling the OTDR and saying, okay, you just tested fiber 1, now we're going to jump to fiber 2. When that finishes, we're going to jump to 3, then to 4, then to 5. And the switch is going to allow you to test all 12 fibers in an MPO with one button push. The other thing that's unique with this is you can save all of your labels as a CSV file, put it on a USB thumb drive, the stick, plug it into the unit, put all your labels right onto the device. So you don't have to enter each label individually, and then test each individual label. So like each one of these is a 12 fiber MPO. If I click on the arrow here, like I did on this label D, it opens up and it shows all 12 fibers. So it's going to give you a pass-fail for the entire MPO, but if you want to look at individual fibers, you can open it up and see all fibers. So it just makes it simple to test. The other thing that this can be used for, an MPO switch can be used for, is we mentioned breakout cables, where it's not the same connectors on both sides. Maybe you've got MPO going in and you've got LCs on the other side. Well, in that case, we can plug a breakout cable. Let me just skip ahead one slide. We can plug a breakout cable into the unit, and this is going to be LCs. So now you can test 12 LC connections with one button push. So you push the button, it's going to test fiber 1, fiber 2, fiber 3, then fiber 4, and when it finishes, and it's going to go right through all 12 fibers by using this. So an MPO switch doesn't have to be used just for MPO cabling. It can be used to speed up any LCs in a data center, or a switch, or a PFP on the side of the road for fiber to the home. So let me just go back to that other slide. And this is just, again, showing how it automates the process. So we download all the labels into the unit. These are all MPO, 12 fiber, 8 fiber, whatever it is. And then when you hit the start test button, it goes through and just tests one right after the other, fully automated. So that's a little bit about it. Here's an example of some of the test configurations. This is testing an actual MPO trunk cable. So we've got our OTDR on one side, MPO switch on the other, a jumper going over to it. This is our launch cable. In this case, we just used a 20-meter single mode launch cable, and we're plugging into that trunk. And then we've got a receive cable on the other end so that we can measure from connector to connector on that trunk cable. And then the other example, or other use case in this, in a data center, is a lot of times you'll have to do incoming inspection on your fiber reels. What this does is now you can splice on an MPO connector onto 12 fibers, and you can if this is 144 fiber, you can just do 12 tests to get all 144 of those fibers tested by using this MPO switch. So it really speeds up that whole process. So that's pretty much it on the MPO. So again, we went through kind of the physical characteristics, keys, pins, unpinned, polarity is type A, B, or C. And then just single mode is angled, multi-mode is flat connectors. Inspection, critical when dealing with MPO cabling. Absolutely critical that you have an MPO-based inspection tool. And then for tier 1 testing, length, loss, and polarity, it's an optical loss test set. And VIAVI's, we call ours our MPO-LX, which again is unique because it can do all three. It's the only true tier 1 certification tool that does length, loss, and polarity. And then if that fails, that test fails with an optical loss test set, then you use a tier 2 tester, which would be the OTDR. And in our case, we can put an MPO switch on there and do all 12 fibers in the MPO by pushing just one button. So with that, we've got 9 minutes left. Just kind of open it up if there's any questions or anything.
Well, first, let me just thank you, Peter. I appreciate your time today and going over this webinar with us. Truly appreciate it. Thank you so much. Great presentation. I will, like you said, I'll leave it open for questions see if anybody has any questions. Give it a few moments. Let me take the presentation from you, actually. I don't have any questions. One person asked, will this presentation be shared? Absolutely be shared. It will be followed up with an email afterwards. There will be a link to the presentation as well as the recording. Well, it looks like that's it. I don't have any other questions coming up. Again, Peter, thank you so much for the webinar today. Great presentation, appreciate it. And I just want to, again, remind everybody on this call, there will be a follow-up email that goes out to everybody with links to the presentation and the recording. So enjoy the rest of your day. This concludes our webinar. Have a good one.
Great. Thank you. Thanks, everyone. Take care.
Thank you. Bye-bye.